Okay, so this one, you have some new rules up here, and honestly, you're not going to use these rules very often, just so that you know. If you see problems that have a pi over 2 in them, you can look back at these rules and see if maybe they'll help you. Honestly, in all the examples today, I don't use them at all, but they're part of this section. So just be aware that they're there, okay? If you have pi over 2 minus x in a problem, you can change it to simpler form. So cosine of pi over 2 minus x is the same thing as sine x. And so forth. These are more like, there are some identities that you don't use very often. They're more to be aware of in case you get stuck somewhere, or you can, you get in a situation where you have this very specific circumstance and you can use it. So we're going to focus mainly on the rules that we learned yesterday. We're going to do some more complex problems. Okay, so here we go. Now this is an interesting idea. The reason that I'm using this, okay, is now, I know this looks a lot like the one we had yesterday, but the reason it's still, we're not actually going to, they're the rules we just learned. We're not actually going to use those rules. So we're going to use the rules we learned yesterday. So what we need to do is it says if cosine x equals -1/4, and x is between pi over 2 and pi, which means that on my unit circle, all right, on my unit circle, okay, I am in this quadrant here, okay, then the cosine of pi over 6 minus x equals what? All right, so we're going to use our rules that we learned yesterday to solve this. So the very first thing we need to do is that in order to solve this, we need to know what sine of x is. So if you use your Pythagorean theorem, okay, sine squared x plus cosine squared x equals 1, okay, you also know that sine, okay, this is important, sine squared x equals 1 minus cosine squared x, right? So sine of x is going to equal the square root of 1 minus the cosine of x. And sorry, that's really messy. All right? So this idea right here that sine x equals 1, the square root of 1 minus cosine x, and then also vice versa, that cosine x equals the square root of 1 minus sine x is going to be important. So let's find sine x first. So we know that cosine x equals -1/4. So sine x is 1 minus, it's a square root, 1 minus the cosine squared x. All right, so it's cosine squared x. All right, so cosine of x is -1/4. So it's the square root of 1 minus -1/4 squared. So it's the square root of 1 minus 1 over 16. Okay, so 1 minus that is the square root of 15/16. So the sine of x equals the square root of 15 over 4. Okay, so that's the very, very first thing we do. The next thing that we do is we say, okay, so if we know that cosine of, so now we're trying to find this cosine of pi over 6 minus x. All right, so we're going to use our rules from yesterday. Okay, cosine of x minus y is the cosine of x the cosine of pi over 6. In this case, it's x if we're using x and y, and then the cosine of negative x. So this is a -1/4, so it becomes 1. No, sorry, it is -1/4. Okay, minus plus sine of x, which is pi over 6, sine of sine of -1/4, which is 15 over 4. Okay, hang on, I need to start over. I wrote this down. Okay, let's try this again. Okay, back to the rule. Okay, let's erase all this. We know we have sine of x is square root of 15 over 4. And too many things written on my paper, too many things written on the board. So sine of x is square root of 15. Alright, so cosine pi over 6 minus x is going to be the same thing as that cosine x, let's go ahead and write the formula down, right? Cosine x cosine y plus sine x sine y. All right. So in this case, x is pi over 6 and y is x. All right. So we're going to go cosine of x. We already know what that is. Or sorry, cosine of pi over 6. Getting confused on my x's here. All right. Cosine of y, which is x, so that's negative 1/4. Plus, okay, sine of x, which is sine of pi over 6, sine of x, which we figured out to be square root of 15 over 4. All right, now, cosine of x, we know from our rules, is root 3 over 2 times negative 1/4, okay, and plus 1/2 times root 15 over 4. This becomes negative root 3 plus root 15 over 8. And that's my answer. Sorry, that was a little confusing. So. Okay. Next example. Right. Another problem that's similar to this. Okay, so we're going to through this. So this one is cosine of pi over 4 plus x. Oops. Okay, so it tells us that the x is in the 4th quadrant. Okay, so we're in this quadrant right here. So what we need to know, we know what sine is. So is cosine positive or negative in this quadrant? Cosine is positive. So when I find the cosine of the x value, we need to just make sure that we leave it as positive instead of negative. So, so let's go ahead and find that first, okay? So the cosine of x is going to be the square root of 1 minus negative 3/4 squared. So it's a square root of 1 minus 9/16, which gives me the square root of 7/16. So the cosine of x is the square root of 7. So I'm going to write that over here so I have it. All right, now in the last example, I got confused because my rule says x and y, but my x is on the is in the y position. So we're going to change this just a little bit so that I'm not getting confused on the x's and y's. All right, I'm going to erase this so that I have root. Okay, then we have the cosine of pi over 4 plus x. So the rule that I'm using is the cosine of x plus y. This rule right here. All right. So I'm going to change these really quick to a's and b's. All right, so that it's a little bit easier. It's hard to see. Sometimes I don't like my word. Screen. Okay, I'm going to call this A. I'm going to call Y B, A, and B. All right. So we're going to go cosine of A, cosine B, sine A, sine B. So cosine of A is the cosine of pi over 4. Okay. Cosine B is the cosine of x, which we solved and we figured out to be the square root of 7 over 4. Now, the sine of A is sine of pi over 4. And the sine of B is this value right here, which is negative 3/4. Okay. So cosine of pi over 4 is root 2 over 2. I hope you know that one by now. That one's the easiest one to memorize. Okay. Minus root 2 over 2 times negative 3/4. Okay. So this becomes root 14 over 8. And this becomes 3. So we have root 14 over 8. Now we have two double negatives, we're going to go plus 3 root 2 over 8. So I'm going to simplify it one more step. Root 14 plus 3 root 2 over 8. And we're going to leave it like that. We don't need to go like that. Next example. I hope that one was a little clearer. So this one's an interesting one. It says assume that sine of x equals 0.8 and that sine of y equals the square root of 0.75, and that x and y lie between 0 and pi over 2, which means everything's going to be positive. Okay? Evaluate the given expression. Sine of x plus y. Okay? So in this, we're going to have to find cosine of x and cosine of y. We can't do this without knowing these two. We have to do that with clear, without knowing cosines. Okay? So what we have to do is we have to find the cosine of x and the cosine of y before we do anything else. So let's go ahead and do that first. So we're going to go the cosine of x is the square root of 1 minus the sine of x squared, so 0.8 squared. Right? So that's the square root of 1 minus 0.64, which is the square root of 0.36, which is 0.6. Right? So right up here, so that I have it, I'm going to write the cosine of x equals 0.6. Now let's find the cosine of y. Okay, the cosine of y is the square root of 1 minus the square root of 0.75 squared is 0.75. All right, I'm not going to write it all in there. Okay, so then I have the square root of 1, the square root of 0.25, which is 0.5. So we're going to cosine of y equals 0.5. So this should actually be a fairly easy problem to solve. There are no radicals. Well, there will be actually. I'm going to think about that. Okay. So sine of x plus y. This rule right here. Right. Sine of x is 0.8. Cosine of y is 0.5 plus cosine of x 0.6 times sine y, square root of 0.75. Alright, so I have a 0.4 plus 0.6 square root of 0.75. Now, on this again, I don't want you using calculators. In the book, they actually give a physical answer for that because they put it in the calculator and found it. I want you to go as far as you can and stop. So, alright. Next example. Okay, x and y are in the second quadrant. Sine of x equals 1/3. Cosine y equals -3/4. Okay, because in the second quadrant, cosine is negative. Find the exact value of sine x plus y, cosine x plus y, and tangent x plus y in the quadrant in which x plus y lies. Okay, so here's the deal. I went ahead and I'm only going to do one. I'm only going to do sine. Okay. Because there's no reason to go through all of these with you. You should have a feel now for these. In fact, I'm hesitating whether or not I should do this example because we've done several of these. But I will do this one. So let's go ahead and figure this out. So first of all, in the fact that we're finding the sine of x plus y, we know that the answer has got to be positive because sine is positive in the second quadrant. So whatever our answer is, make sure that it's positive. If it's negative, switch it back. If you're finding the cosine, which we're not doing, the answer needs to be negative. If you're finding tangent, the answer needs to be negative because we're in the second quadrant. All right, so let's go sine of, we know sine of x, we know the cosine of y. We're missing the cosine of x and the sine of y. So let's go ahead and solve for those. So the cosine of x equals the square root of 1 minus 1/3 squared, which is 1/9. So it's going to be the square root of 8 over 3. All right, I'm not going to go through all that work. You should know how to do these by now. And then the sine of y is going to be the square root of 1 minus 9 over 16, which gives me the square root of 7 over 4. All right, so now I have these values. Let's go ahead. We're gonna just do sine of x plus y. I'm not going to do all of them because I don't feel like I need to do that on this video. It's already long as it is. Okay, so sine of x plus y is going to be sine x 1/3 times cosine y, negative 3/4, plus cosine of x square root 8/3 times sine of y square root of 7/4. Okay, so this becomes negative 1/4 plus square root of 56 over 12. And you don't need to go any further. Again, I don't want you to, don't worry about the fact you don't have calculators, I want the answers like that. Okay, I have 2 more examples for you. 2 more examples for you. This is actually going to get away from using numbers and just symbols. So I want you to prove these identities. Okay, so back to proofs. Okay, the cosine of x minus pi is equal to the negative cosine of x. Okay, this is one of the identities I think we learned in section 9.1, one of the periodicity identities. So what we're going to do is we're going to rewrite using this rule. So the cosine of x minus y, okay, is this rule right down here, so we're going to use this one. So I'm going to go cosine x, cosine y, cosine x, cosine pi, plus sine x, sine y, plus sine x, sine pi, okay. Now the cosine of pi is 1, or is negative 1, sorry. So we're going to end up with a negative cosine of x. Okay. And the sine of pi is 0, so this is plus 0. So the answer then is negative cosine of x. That's a nice proof, huh? Alright, so that's that one. Now I have one more. Okay. I want to prove this one. Now, this is a tricky one. Alright, so if you look at this, you have sine x cosine y equals 1/2 sine x plus y plus sine x minus y. Now, in this case, whenever you approach a proof, you can do it in many different ways. All right. I looked at this and I said it's going to be much easier for me to manipulate the right side of the equation instead of the left. So we're actually going to use this side of the equation to prove the left side. Okay. So I'm going to manipulate this side. So using these rules, okay, I'm going to write this. It gets a little long here. So we're going to manipulate this side. So I'm going to have 1/2 times, a big parenthesis here, sine x plus y, which is sine x cosine y minus cosine x sine y, okay, plus sine of x minus y, which is sine x cosine y minus cosine x sine y. Alright, so now these are all still within the parentheses. I can go ahead and cancel some stuff out. I have, I think it is, this should be a plus sign, I'm sorry. Okay, when I do sine x plus y, this should be a plus sign in here. I was looking at the wrong one. Alright, so I have a positive cosine x sine y and a negative cosine x sine y, so I can cancel those out. Okay, and I'm left with 1/2, sine x cosine y and sine x cosine y are the same thing, times 2 sine x cosine y. Okay, 1/2 and 2 cancel each other out, and I'm left with what I have right there. Okay. And that is it. I knew this was a long video. I apologize. Good luck with your homework. This is kind of a tough one.